All right, everyone, and welcome to the Test 2 practice exam that is on Dr. Adwalhab's Moodle page. So we're just going to go through all these problems one by one. Okay. So our very first problem, granted we have the answer right here, so we can go ahead and check. But they give us this circuit, and we notice that we'll have a capacitor here, inductor here, resistor there, and a resistor there. And they ask us to find the steady state value of I3. So I3 is that current right there. So current traveling through the 100 ohm resistor and the 1 Henry inductor. Okay. To solve this problem, we need to know values of steady state. So how do these elements interact in steady state? So real quick on the side here, actually I'll save that for the concepts video, but let's just go ahead and work out the actual problems here. So we will replace all of our elements operating in steady state with their respective parts and pieces. Let's go and drop our 200 ohm resistor there. It's 100 ohm resistor there. This is I0, which was 2 amps. This is VO, which is 800 volts. Okay, and then we still have I3 traveling down that way. Okay, so in steady state analysis, when we have current running through a capacitor, if we let it run to infinity, so time goes to infinity with current present, your capacitor will turn into a clipped out wire because it reaches the maximum capacity. You can't store any more voltage in it, so it clips itself out. And then your inductors are going to act like straight wires. So what this means is that these inductors want to resist current flow. So they want to prevent this current from getting to the other side. But eventually, if you let it run for long enough, the current flow just completely is constant through it. And we can just treat it like a regular wire. So that's what we did here. So as these values went to infinity, we took this knowledge on the right-hand side, and this is where our capacitor was, replaced it with the clipped out wire, and there's our inductor. So we see the I3 right here. This voltage source here does nothing for us because it's connected to this clipped out bit. So it can't really produce anything for us. It's not on a closed loop. But if we look at our current source over here, we see that it'll produce 2 amps there, produce 2 amps there, 2 amps there, and it hits right here. It notices that it can't go to the capacitor because it's open, so it just sends all 2 amps down that way. So therefore, our I of 3 is equal to 2 amps. Okay. Pretty basic, straightforward problem. Shouldn't be too difficult.